Welcome back to my channel Electronic Science Tutorial. Today is the 19th class of Operational Amplifier. Today I will discuss the Schmitt trigger by using an op-amp. Okay, so in my previous class I will talk about the non-inverting comparator circuit and inverting comparator circuit. Today I will discuss the Schmitt trigger by using an op-amp. So without any time waste, let's start our class. So what is the definition of Schmitt trigger circuit? That is, a Schmitt trigger is a type of comparator circuit with hysteresis. What is the meaning of hysteresis? It has two different threshold voltage for switching the output state. This feature helps to provide noise immunity and a clean digital output from a noisy or slowly varying input signal. When implemented using an op-amp, the Schmitt trigger provides stable switching behavior. So this is the proper definition of Schmitt trigger circuit. A Schmitt trigger is a type of comparator circuit with hysteresis, meaning it has two different threshold voltage for switching the output state. This feature helps to provide noise immunity and a clean digital output from a noisy or slowly varying input signal. When implemented using an op-amp, the Schmitt trigger provides stable switching behavior. Okay. Now, what is the circuit diagram of Schmitt trigger circuit? This is the circuit diagram of Schmitt trigger circuit. Since the positive feedback is given to the non-inverting input terminal, the output is saturated either in the positive or negative direction. Okay, and this connection is known as hysteresis connection. If output is positively saturated, that means upper threshold voltage, as long as the input voltage is less than the upper threshold voltage, the output will remain positively saturated. As the input voltage is increased slightly, then a point is reached where the input voltage is more positive than the upper threshold voltage. When this occurs, op-amp is driven into a saturation as the error voltage changes polarity. This negative voltage is called lower threshold voltage. The output will remain in this state as long as the input is more positive than the lower threshold voltage. Okay, this is the proper definition, proper working principle of this circuit diagram. Once again, I will talk about this topic, that is, since the positive feedback is given to the non-inverting input terminal, the output is saturated either in the positive or negative direction. If output is positively saturated, upper threshold voltage, as long as the input voltage is less than the upper threshold voltage, the output will remain positively saturated. As the input voltage is increased slightly, then a point is reached where the input voltage is more positive than the upper threshold voltage. When this occurs, op-amp is driven into saturation as the error voltage changes its polarity. This negative voltage is called the lower threshold voltage, and the output will remain in this state as long as the input voltage is more positive than the lower threshold voltage. Okay. Next, what is the working principle of Schmitt trigger? The working principle of this Schmitt trigger is the upper threshold voltage, that means which is represented as VUT. When the input voltage Vin exceeds the level, the output switches to negative saturation voltage, that is minus VCC. And the lower threshold voltage VLT, When the input voltage Vin falls below this level, the output switches to the positive saturation voltage, that is plus Vcc. The hysteresis is the difference between the VUT and VLT. That means the upper threshold and the lower threshold difference is called the hysteresis, which prevents the circuit from responding to small noise fluctuations in the input signal and providing a stable digital output. So this is the working principle of Schmitt trigger, where we get two voltage level. One is upper threshold voltage level when Vin is exceed the input voltage level, and the output is switches to negative saturation voltage, that is minus Vcc, and the lower threshold voltage when the input voltage falls below this level and the output switches to positive saturation voltage, that is plus Vcc. And what is the hysteresis? Hysteresis is the difference between the upper threshold and the lower threshold voltage level. Why we do this hysteresis loop? To prevent the circuit from responding the small noise fluctuations in the input signal and which providing a stable digital output. The mathematical representation of this working principle, that is upper threshold voltage VUT, is represented as R2 divided by R1 plus R2 VCC, and the lower threshold voltage VLT is represented by R3 divided by R3 plus R2 into minus VCC. So this is the mathematical representation of upper threshold voltage and the lower threshold voltage. Okay. Next, what is the graphical representation of the Schmitt trigger circuit? This is the graphical representation where this solid color blue line is for input voltage. This upper threshold voltage is represented by green dotted line, lower threshold voltage is represented by red dotted line, and the output voltage is represented by yellow color solid line. Okay, so this is the upper threshold level and this is the lower threshold level, that is this red color line. Okay, now what we will compare, that is the how long Vin is greater than V reference V input volt upper threshold level or lower threshold level. This is the positive half cycle. This is at from this point to this point we get the positive half cycle, and from this point to this point we get the negative half cycle of the input sinusoidal signal. So how long the input sinusoidal positive half cycle is greater than the upper threshold level in this time period? In this time period we get the upper threshold level, that is VUT. So we get this yellow color line, that is positive VCC. Whenever this input voltage is less than the lower threshold voltage, we get the negative VCC. Again, when input line, that means the blue line, is greater than the upper threshold level, that means this green color line, this blue line is greater than the green color line, we get the positive VCC. Whenever the blue color line is less than the red color line, we get the negative VCC. In this way, we get a square wave output at the op-amp output terminal. So, this is the graphical representation of Schmitt trigger circuit. There is a basic difference between non-inverting comparator and a comparator inverting comparator circuit. Non-inverting comparator is also give the square output. Inverting comparator is also give the square output. But in case of Schmitt trigger, we get a stable output, stable square output, noise-free stable square output. Because in the non-inverting comparator circuit, we applied a input voltage at the non-inverting terminal and a reference voltage is applied to the inverting terminal. And we compare these two voltage level in case of non-inverting. In case of inverting comparator circuit, again this work is repeat except the terminal has been changed, right? But in case of Schmitt trigger using an op-amp, we get two threshold voltage, that is upper threshold voltage and lower threshold voltage. We compare this input voltage, these two voltage level, one reference volt by using and one reference voltage we cannot compare the input voltage. We compare the input voltage using two reference voltage, that is one is upper threshold level and the another one is lower threshold level, and from the mathematical representation of upper threshold level and lower threshold level we saw that this value is depend on the resistor. Okay, so this is more stable. This circuit is more stable. So whenever the input voltage is greater than upper threshold level, we get the positive VCC. How long this situation is occurred? As long as V in is greater than V upper threshold voltage. Whenever V in is less than lower threshold level, that means VLT, we get the negative VCC. And in this way, we get the square output at the output of the op-amp. So this is the graphical representation of Schmitt trigger. I hope you understand this topic. Thank you. If you like, do like, share and subscribe my channel. Thank you.